So, hi everyone, welcome to the World of Ethereum and Smart Contracts workshop. As Ada, I'm just going to be introducing what's going to happen today. We're really happy to have you all here and thank you for coming. And thank you, Raphaelle, for the time that you're giving the community. So, before we start, I'm just going to give a brief explanation of the format of the workshop. Raphaelle is just going to start out with some theoretical concepts, then a hands-on demonstration, followed by a Q&A. If at any point during the workshop you have a question, you can find the Slido link in the description. And for the hands-on part, if you want to follow along,
Hey everyone. So Ala is experiencing, I guess, technical difficulties. My name is Raphaelle Akhras, and I'm a graduate student at AUB. As part of my thesis titled Securing Smart Grade Communication Using Ethereum Smart Contracts, I've basically researched, experimented, and worked with Ethereum. So in this presentation, we will be delving into this world of Ethereum. And I really must note that this is a general presentation and we don't really go into the details of maybe consensus or the math behind the blockchain platform. So the plan for this presentation goes as follows. Basically, we will first start off by introducing what blockchain is, the concepts that are tied to it, the use cases for blockchain in general. We will then discuss Ethereum and its parts, its many parts actually, specifically decentralized applications and smart contracts. Finally, we conclude with a nice, simple smart contract application. And if we have time, we'll do another like more complicated smart contract application. And as always, so the first simple one will be a Hello World smart contract, so a rite of passage, basically. So let's begin. So how did blockchain first emerge? There's this person or group of people that came up with the idea of Bitcoin. So the pseudonym was given was Satoshi Nakamoto. So have any of you heard of Bitcoin? I assume, yeah, probably, right? Definitely. It took the world by surprise and it's just the new emerging technology, right? So soon after, every company and sector out there was researching its benefits and its trade-offs and its usefulness in their field of work and was trying to incorporate the blockchain technology into what they were doing. So what is blockchain? Blockchain is a peer-to-peer network. Okay, you guys might say, okay, but what is a peer-to-peer network then? Well, it is where interconnected nodes, and let's call these nodes computers, so these nodes share resources amongst each other without a centralized administrative system. So as you can see in the figure, there is no central entity, right? It makes the blockchain itself a decentralized entity. So what does it mean that blockchain is decentralized? Well, centralization and decentralization basically refer to levels of control. So a centralized system is a system that uses maybe a client-server architecture where one or more client nodes are directly connected to a central server. So disadvantages could include maybe bottlenecks or system failures if nodes lose connectivity or something like that. So decentralized systems, however, are systems where every node makes its own decision. Well, the final behavior of the system basically is an aggregate of decisions of the individual nodes, for example. Control is shared amongst several independent entities. And the concept of aggregate decisions is important in blockchain, and we will discuss it briefly in the upcoming slides. So before doing so, it's important to note that the third concept is a distributed system. So distribution refers to differences of location. And a distributed system is a model in which computers located on networked computers communicate and coordinate their actions by passing messages. So we'll see why that's important. So what is distributed about blockchain? Why am I saying distribution is important, or distributed network is important? Well, as we said, blockchain is a peer-to-peer network. It is also composed of a distributed network of ledgers. So what does that mean? A distributed ledger is basically a database that exists across several locations or among multiple participants, and this creates a tamper-proof log of activity. Okay, so now you say, then what is a tamper-proof log? Well, basically, the distributed ledgers are secure. So no one can edit them or delete them. They can only append to them. So this makes blockchain a secure space. In addition, the idea of being distributed really eliminates the need for a central authority, right? So we said it was decentralized, or an intermediary process to validate or authenticate actions that occur on the blockchain. So basically, blockchain provides trust through trustlessness, right? So these actions are called transactions. Okay, and we're going to discuss what transactions are later. And they can be verified by certain nodes. And again, this eliminates, the need for a central authority or a trusted third party. So for blockchain to make decisions, they really need to come to a mutual decision using something called a consensus mechanism. So it's a dynamic way of basically reaching an agreement in a group. So consensus makes sure that an agreement is reached, which could benefit the group as a whole. And there are many different kinds of consensus mechanisms, including proof of work, proof of stake, delegated proof of stake, proof of identity, so many different ones, right? And we obviously don't go into the details of the mechanism here, but we will say that, okay, let's see the process, right? So let's go over the process of adding transactions. So as we said, we'll really go into what a transaction is later, but it's basically like, okay, I'm sending you money. I'm completing a certain function in a smart contract. So we'll discuss that later. So we don't really go into the details of consensus, but we'll just go through the general flow. So someone in this peer-to-peer network we just discussed processes a transaction. So they want to create a transaction. And this transaction can involve the cryptocurrency, smart contracts, records, or other different things. Okay, so the transaction is broadcast to this network of nodes, and it waits to be picked up by like these delegated nodes that kind of complete this consensus, right? And so the transaction is basically put into a pool. So there's just like a bunch of transactions that haven't been confirmed yet, right? So these specified nodes that are called miners, I'm just going to say that very briefly, miners, they select these transactions, right? So they select the transactions from the pool and they put them into a block. So obviously they verify them, they validate them, and then they put them into this block. And this block now is verified, right? And once it's verified, it is broadcast into the network and it is placed onto the distributed ledger. So a node on the blockchain will have a blockchain account, right? So this account has a public private key pair. So what does that mean? So basically, a public key will be distributed to the blockchain network. So I have, well, let's say Alice. Alice has a public and private key. So she will distribute her public key. She will send it out to the network, right? And the private key should be stored locally. And it's very important to keep this private key safe. Now, as we mentioned, transactions will occur on the blockchain, right? So in Bitcoin, an account can send another account a certain amount of Bitcoin, right? So I can send, or Alice can send Bob some money. So if Alice wants to send Bob 10 Bitcoin, so how can Bob know that the transaction received is actually from Alice? So blockchain basically has a mechanism set in place for this. And what do they use? They use public key cryptography, specifically digital signatures. So what they do is, what Alice does is actually using the private key, a digital signature can be created so that anyone with the corresponding public key can verify the message and can actually verify that the message was from the owner of this public key, right? So in this example, Bob will use Alice's public key to verify that the transaction, the 10 Bitcoin that he received, was actually sent from Alice. So blockchain really makes extensive use of public key cryptography. So before going into discussing Ethereum in detail, let's comb over a few of the differences between Bitcoin and Ethereum. So Bitcoin was created as an alternative to national currencies and thus aspires to be a medium of exchange and a store of value, right? Ethereum, however, although having its own currency, is a platform to facilitate programmatic contracts and applications, again, okay, via its own currency. You can notice Bitcoin has Bitcoin, Ethereum has Ether. Okay, but both of these blockchains, at the end of the day, these blockchain platforms do not depend on a trusted third party. They are decentralized and others. So we have a bunch of other details here. We really don't need to go into these. So what we're going to do next is discuss public versus private blockchains. So there are many different types of blockchain platforms. There are public and private blockchains. And in addition, there's a bunch of others like consortium and even hybrid blockchains. So we don't really go over the details of these different types. I'm only going to mention the different types and why they're used for like different purposes, right? So obviously there's public and there's private for a reason. So by choosing one over the other, you have to weigh the pros and cons of each. So let's just give an example. So for example, if you want to pick a public blockchain, you will achieve decentralization, trustless, secure, openly transparent network. Like that's what you're going to have if you pick a public blockchain. However, the transactions made will be very slow and we will have like some scalability concerns. But if you were to pick a private blockchain, for example, you will achieve fast and scalable transactions at the cost of lower security and centralization, right? So it's not as decentralized as the public blockchain. So blockchain can be used in any sector in today's society. It can be used anywhere, ranging from farming technologies to smart grid communication. And I've added a few papers over here that show the different ranges in which blockchain technology is used. So as you see in the first one, it's a sharing app using smart contracts. The second one is road toll collection. So obviously that's abroad, not in Lebanon, on highways. You have the third one where blockchain is used for security management. So blockchain can be used to provide integrity, authentication, auditability, so many different things. We also have Ethereum or blockchain here specifically, Ethereum, in smart homes. We have it as securing smart greenhouse farming. So you can see just it's like a broad spectrum of things. Okay, so now we get to Ethereum. So Ethereum is another blockchain platform. It's also a peer-to-peer network of nodes, and these nodes can actually execute contracts in addition to the other transactions. Okay, so Ethereum is basically known as a transaction-based state machine, where every transaction changes the state of the blockchain. So if I send something that is a send action, which we will discuss, this will change the state of the blockchain. Okay, and we will see in future slides these details. Okay, so it basically revolutionized the crypto space by bringing in the concept of smart contracts and decentralized applications. So while Bitcoin was and still is leading at the top of the table with the greatest market share and like financially, Ethereum was making remarkable waves in its own way to like reach the level of Bitcoin, right? Especially since Ethereum is way more than just a currency, as we said. So a small note about Ethereum, if you ever want to check out the blocks that are created or how things are added to the Ethereum network, there's something called Etherscan right here, and it's basically a block searcher, so a search engine that allows the users to easily find a transaction that was created and added onto the blockchain. Okay, so we can see in this figure basically the Ethereum network of connected nodes, and this network shows the smart contracts, it shows people, it shows shopping carts and iPhones and messages, and so it really shows how Ethereum really can be anything at this point in time. So let's just go into a few of the details related to Ethereum before goes the externally owned account, and those are usually people, right? They're users, and they also contain the public-private key, as we discussed before in blockchain in general. So the externally owned account can do what? It can send transactions, right? And being that it can send transactions, what can it also do? It can also sign these transactions, right? And so we can send and we can sign. What else can we do using this externally owned account? We can also receive transactions. Okay, so all of these can be done using the EOA. For the contract account, it's basically an address of the deployed smart contract. So we're going to get to that soon. But all we need to know here is that there's a contract, and once this contract is on the blockchain, it has an address. Okay, just like the people have an address, the contract has an address. Okay, and this contract account cannot do the same things that the EOA can do. So it can only receive transactions and execute smart contract code. Okay, so we'll see what that means in a bit. So we didn't really discuss transactions in like a slide of its own. So I'm going to discuss transactions like in the Ethereum context here. So a transaction can be anything from sending Ether, which is Ethereum's cryptocurrency, to another account. It could be deploying a smart contract, and deploying means putting it onto the network, right? So deploying a smart contract, or it could be communicating with a smart contract as well. So when a transaction is created, data is written to the blockchain. So remember, we said that Ethereum is a transaction-based state machine. So here, when we create a transaction, the data is written to the blockchain, and this updates the Ethereum state, as we mentioned, right? So these transactions are available to any node in the network, right? And how does that happen? It's on the distributed ledger, correct? So these transactions are open, they're transparent, and they're available to everyone. So for example, if I want to send Ether, what I will do is I will send it to their Ethereum account, right? So what blockchain does is the whole process that we discussed before, right? It signs it, all of that, and then it goes through consensus, and then it adds it to the blockchain network. Now that the transaction is on the blockchain network, it can be viewed by anyone, right? Using this distributed ledger, and that's that, right? So gas and fees. Here I'm gonna discuss like what these concepts really mean. So you guys know gas in like life terms, I guess, and you know what fees are. But in Ethereum, these are different, right? So in Ethereum, to send a transaction, right, to create a transaction, an account must pay a fee. So if Alice wants to send Bob the transaction, she needs to pay a fee. And how is this fee calculated? It is calculated by considering the amount of gas used. So then you're like, gas? What is gas? So gas is basically used to measure the complexity of a transaction. So say, for instance, a transaction is a function, right? And it's a function that adds two numbers, like 2 plus 4. So consider another transaction that takes a number and multiplies it by another, then divides it by the sum of the modulus of two other numbers. So obviously the second function is way more complicated, right? It's a complex function. So obviously this function, the second function, consumes more gas. So calling the second function will cost way more than calling the first function. So the fee of the second one will be more than the fee of the first one. So as you can notice, the gas and the fee are directly related, right? So the gas consumed by a transaction is based on the number and complexity of instructions, right? So first we said we're just adding two numbers. In the other one, we're multiplying, we're dividing, there's the modulus, bunch of stuff happening, right? So the gas consumed will affect the fees that need to be paid by the transaction creator, right? So I hope that was clear. So this is just an example of what will happen on Remix. We're actually going to be using Remix later. So what we have is like the transaction hash, the contract address, meaning, remember we said there's the externally owned account and there's the contract address. So the function that we've created here is on this contract address. So this is the contract address. And then we have from. What is from? From is basically who is sending the transaction. So who is calling the function, right? So from is the person's account, I guess, right? So this hexadecimal number. And then you have to. To is basically who are we sending it to? We're actually calling a function on the smart contract, right? And we are calling here the constructor. Okay, so that's what's happening here. We have the cost and we have the gas that was consumed. And actually, this is the gas limit, right? So this is how much gas was provided this will be important. I'll discuss this in a bit, right? So this is the total amount of gas provided. So 3 million gas, but only a certain amount of it was used, as you notice. It's not the full amount, okay? So we'll see this again in the example that we create. So finally, we get to events. That's the final subtopic of Ethereum before getting to the smart contracts and decentralized applications. So an event contains data about the change of the blockchain state. So remember, I said if you send a transaction, a change in the state will occur. So this event can contain this data, right? So they facilitate the communication between the user interface of an application and the smart contract, and we're going to see what that really means. So events are emitted through smart contract functions. We are actually going to do that in our smart contract, so that's cool. And they are logged onto the distributed ledger, so they're just like any other transaction, right? So we log that an event has been emitted. That's just the whole idea, right? And events can also be filtered. So I can say, okay, I only want the event from this account, or I only want the event that concerns this amount of money, like that. So events can really be filtered, and this can really help with the front end on your application. So we'll see that. So we're going to discuss an example of this. So finally, we get to a decentralized application. So the main functionality of Ethereum is the existence of the smart contracts, right? So what we will discuss in this slide before getting into the smart contract is the general idea of what a decentralized application is, right? Because a smart contract is part of the decentralized application. So a decentralized application, as you can infer from its name, is decentralized, right? So it's on the blockchain network, so it is decentralized. So there are certain properties that a decentralized application should have, and these properties are adapt should be deterministic. What does it mean to be deterministic? It means for the same input, I will give the same output, right? Adapt should be isolated, and this is very important. So why should adapt be isolated? So Ethereum executes its smart contract using the Ethereum virtual machine. We're not really going to go into that, but why does it do that? It does that because anyone on the blockchain network can upload a smart contract, right? Or it could communicate with the smart contract. So this could lead to actual bugs or viruses on the network, right? Or on the specific nodes. So this must be sandboxed, right? So it's isolated. So that's why they have the EVM, the Ethereum virtual machine. Again, we're not going to go into the details, but just know that it's there. Okay, and finally, adapt should be terminable. What does that mean? So an application here must be capable of termination in a given time limit. So remember when we talked about gas and we said there's a gas limit? So there's a certain amount of gas that's allowed by a function, and I will set the gas limit. I will say, okay, for this function, the maximum I'm going to do is 3 million gas. And so once this gas runs out, the smart contract will have to stop executing. So this ensures that it is terminable. And this is a really important feature of Ethereum where the gas limit will basically stop hackers or others from bombarding the system with denial of service or anything other. Actually not going to go into that. That's a bit higher level than this. Okay, so creation of adapt basically is composed of two things, actually three things, but it's the front end, it's the back end, and it's the middle, right? So the front end can be created using HTML, CSS, React, Angular, Vue, JavaScript, all of these different things for the front end. And the logic of the back end is actually provided by the smart contract, right? So the decentralized application is front end and back end, and the back end is the smart contract, which we will discuss in this next slide. So many components must be used to link this front end to the back end smart contract, which is basically the Ethereum network, right? Because when you link to a smart contract, you're basically linked to the Ethereum network that contains the smart contract. So through the use of like JavaScript, we you can actually, you don't need to use JavaScript, but you can create the necessary files to compile, test, deploy, and interact with smart contracts. So there's React, you can say React is the front end, and we can say that there's this thing called Web3, and Web3 is an important collection of JavaScript libraries. So you're going to use Web3 JavaScript, right? If you're using JavaScript, and this is used to interact with remote or local Ethereum nodes. Okay, so could be a bit high level, but like that's the general overview. And then there's this thing called MetaMask, and MetaMask provides a secure and simple way to connect to a decentralized application on the blockchain network. And basically, MetaMask provides the Ethereum address. Remember, we talked about externally owned account and it has an address. So MetaMask provides you with this Ethereum address, and this is the address you can use to deploy smart contracts and interact with smart contracts. Okay, so now we finally got into smart contracts. So what is a smart contract? Well, it's a set of self-executing instructions between two parties or more, which really don't need to be supervised or enforced by a trusted third party, right? So obviously, we're not going to have a blockchain network that has a decentralized application that needs a trusted third party, right? Because the whole point is that we've eliminated this third party. So it contains the terms and rules and conditions of agreement that are established between these different parties, right? It's like a basic contract, and it's put into code and it's added to the network, right? So if an event specified by condition occurs, the code will automatically execute. We're going to see what's happening. Maybe this sounds like a bunch of jargon, right? Technical jargon. So once executed, terms of the contract will transfer value to relevant parties, like, for example, transferring Ether or completing a function. It doesn't matter right now. So the transaction, of course, will be recorded onto the blockchain. Okay, so these are the different steps that could occur when you want to create a smart contract. So first things first, designing a token. We really don't go into this, but you can design your own digital currency and create a tradable computerized token. We don't go into this. So the logic here is, okay, we're going to implement a smart contract, and we implement a smart contract in our, like here, we're going to use Solidity, right? And Solidity is the programming language that we use. It's the most popular programming language, actually. And what we do is we're going to put the rules and we're going to find the sequences that occur in our smart contract. And parties should agree on the contents and objectives of the smart contract, right? So we're done implementing it. Now we need to test it. So it should be deployed to the blockchain network. And before doing that, we need to make sure that our contract runs smoothly, right? So we need to emulate a real environment and test and make sure that the contract works as expected. Then you're gonna get acceptance and revision. You're gonna accept. People are gonna say, okay, this is good. Let's review it. They'll check it out. Okay, this is fine, whatever. Then we get to the deployment stage. So what is deployment? The deployment is saying, okay, I have my contract with me. Now I need to send it out to the blockchain network, right? So I'm gonna just push it onto the blockchain network so that everyone can use it. It's basically submitting the contract code to the blockchain, where the transaction will be the smart contract, right? And once the transaction is added to the distributed ledger, what happens? It is now visible to everyone. So just like any other transaction, the smart contract is now visible to everyone and can be used, can be interacted with, can be observed. Support is really just making sure that everything's going smoothly. It's not really that important. So these are the steps. So to just the implementation steps, actually. So smart contracts are written in Solidity, and then they're going to be compiled and tested. Once tested well and comprehensively, we go to the deployment. And then so the deployed contracts can be instantiated. So basically, when you create a contract, it's basically like creating a class in Java or Python or whatever. So when you have a class, you can create multiple instances of this class, correct? So same here, you can create multiple instances of the contracts. So these contracts, as we said, can be observed, and accounts can interact with these smart contracts. So what we are gonna do now, it's been half an hour. Okay, so what we're gonna do here is we're gonna create our own application. And we're going to use the Solidity programming language, as we said, to write our smart contracts. So first things first, we are going to use Remix. And Remix is used for creating and testing our smart contracts. So this is way easier than actually creating the environment on your own laptop. It's way less complicated, so there's no need to download any software. Everything will be done online. And if you actually want to save your smart contract locally, you can create a file on your PC and just like copy paste it. That's fine. You can copy paste the code from the Remix editor and then keep it. So let's just do this. We're gonna be a bit slower here, so that's pretty normal. So first things first, we're gonna navigate. Let me just share my whole screen, right? So let's. Okay, so as we said, we are gonna go to Remix, right? So I've already done that here. Let's go here. Okay, and you're just gonna navigate to that. And in the window, you will see the environment section. So we're gonna click on Solidity. So right here, we're gonna see the environment section, and we're gonna click on Solidity, as we said. Okay, so this will open the Solidity compiler in the left panel. Perfect, there it is. And we need to select the compiler version, this one. Okay, so we just go here. We can select any version, but this is just the version for like the simple smart contract. So we'll just go with whatever's written. No. 4.16. This one. Okay, so once we've done that, we need to navigate to the File Explorer tab. So basically that is on the left over here. So we're going to go over here. And we want to create our Solidity file. So let's do that. So we are going to create a hello smart contract, right? So hello world, we all know hello world, right? I hope. So let me just open that up. So we are going to create a file called, here, let's call it, actually capital, right? Or did I call it hello? I called it hello. Okay, hello.solidity. Okay, so now we have this Solidity file called hello, and this will contain our code for the smart contract. So first things first, what we need to do is we need to declare the version of Solidity we are using, right? So we're gonna go here step by step. Well, actually, let me just copy paste the whole thing and then we'll discuss it step by step because that's like way simpler. Okay, so in the first line over here, what we're doing is we are declaring the version of Solidity. So we're using, as we said, 0.4.16, right? So we already specified that over there in the compiler, correct? And so basically we're declaring the version that the compiler will know, like, so that the compiler will know like how to perform, right? Because each different version could come with like different syntax or updates, you know, so it depends. Okay, so contracts are declared with an uppercase first letter. So here we go. We say contract hello, and then we have our open and close curly braces. So we've declared that this is our hello smart contract. So whenever we are gonna be well, not we, when it's deployed onto the Ethereum network, what's going to happen is it's going to have its name hello, but what is going to happen, it's also going to have its contract address, right? So it's going to be deployed and it's going to have, okay, the contract address. So it's going to be hello and contract address. Okay, so they basically act as classes like in other programming languages, just like I said before, so Python or Java or C++ or anything else, right? So when we declare a variable over here, what we've done is basically this is in the code block of the contract, and so we also specify that it's publicly visible, right? So not just it's not just message, it's public and it's a string, right? So obviously we can notice that there are types here, so it's not loosely typed. We have our types. So if I'm going to give a wrong value for message down here, it's going to give us errors in the smart contract. Okay, so the variable message is a storage variable. So it defines the contract state. So that if we edit message, this will create a transaction. This transaction will edit the Ethereum state. Like, this is something I just keep repeating because that's basically the like whole point, right? We're changing the state of the Ethereum network. Okay, so using a send function, remember we said send function. So using a send function, we can change the state. And if we use a call function, well, that really doesn't change the state. But I really don't go into call functions over here, but call functions are basically functions that return values. So what they're doing is they are getting a value from the smart contract and just returning it to you. But a send function will do what? It will cost money, right? It will cost a fee, a certain fee, and it will be placed onto the blockchain. So a transaction will be made and the state will change, right? So you see the difference between the send and the call ones. Okay, so for the contract to be used, there has to be a function that really initializes it, as we know. So this function is the constructor. The constructor's name will match the name of the contract itself. So each time an instance of the contract is deployed, the constructor function will be invoked automatically. Okay, so and obviously there only can be one constructor function per contract. Okay, and the constructor in this case sets the message variable to the value passed. So here I say function hello, and I pass it an initial message. And obviously this function is public. So what I do here is I set the message, so my variable here, to this initial message. That's what happens in the constructor. That's it. Okay, so the only other function of this smart contract is the set message. So what really happens in the set message function? So we also notice that it's public, and we notice that we are passing it a value, a value. So this value, as we notice, both times they're strings, right? So what we're doing in the set message function will allow a user to change the value of the message from its initial value, right? So both the set message function and the constructor function have public visibility, meaning that anyone can call the function once the contract is deployed. So not just the owner of the contract, right? So if the owner were to be the one like only being able to execute a function, that would be a private function. Okay, so we have it over here. We've saved it. As you notice here on the side, we have a little check here saying the compilation is successful. Okay, so what we want to do is go here to actually test it out, right? So what we're going to do here, you can notice many different things. We have the JavaScript virtual machine. We can change that into injected Web3 or Web3 providers. So these are used. Injected Web3 is used when you use MetaMask and when you actually create the application with a front end and back end. So here we're just testing before even getting to that. So we're using the JavaScript virtual machine. And then we have these different accounts that we can use, and they all have 100 fake ether, so it's not real money. And here you have like a gas limit. So what we have is our hello solidity file. So here it's telling us, okay, you don't have any contract instances. So let's click deploy. Okay, so actually let's close this off right here. So if I want to deploy, like what I did before is I deployed using an empty header. So let's just actually give it a value. So hello world, right? And I'm going to click deploy. And what's going to happen is you notice here that it says check, right? It gives you, okay, this worked. And if you open it, and let's just, right? So what you see here is that, okay, the string initial message is hello world. So that's what you have at the end of the day. You've actually said, okay, I've set my like my initial message, right, to message, and it's hello world. So if we open it here, we can see the different things that we can do on a on a smart contract, right? So there's two different things. There's message and there's set message. So what's message? We didn't really create anything called message. So what happens in Solidity here is that the fact that this variable is public means that it will be assigned a getter. So message over here is basically the getter of the message variable. So when I click on message, I will get the string, right? And I will get its type, obviously string, and I will get the value of message, which is hello world. So now we have the second thing over here, which is the set message, which is the function I can use, right? And we already said this, and then we're gonna say, okay, hello, me. Okay, so when I do hello, see, they don't even know my name. So when I say set message over here, let's scroll here. What's going to happen is it will also be approved, right? Nothing wrong happening. So now why am I saying these will be approved? These are still very simple, and like it's actually, I'll show you how to like get it to fail. But if I say hello Raphaelle, it will pass because nothing wrong, and then the message will actually change to hello Raphaelle. So if we want to give an example of a send function and a call function, this is a send function, right, where it changes the state of the Ethereum blockchain, and this Ethereum state, and this is a call function because I am retrieving something from the smart contract. I am just calling. I incur no fee. I produce no transaction. Okay, so you see the difference. So how can I fail it? Well, basically, you're gonna have to put like maybe nothing. Who knows? No, even that it takes it as an empty string probably. Well, that's not a problem. We're gonna go into, yeah, it takes it as an empty string, see over here. Okay, so we're just gonna go over how to fail it in the next smart contract. So I hope you guys understood what's happening in this contract, all the way from, you know, the beginning where we're setting the version of Solidity to the creation of a contract, to the variables in the contract, and then to the constructor, obviously, the past parameters, and the just general function over here, right? So I hope this was all clear and, you know, nice, I guess. So you've just created your first Solidity smart contract, and we will go to the next one over here. Now this next smart contract is going to be this one. So I am going to create a banking smart contract. Okay, now, like, what is a banking smart contract? So we're just creating a contract for the smart contract. It's just, so we have fields, right? And we're going to discuss what these different fields are. And it's going to be really cool to actually write this out, I think. At least it was cool for me. And then we're going to have the methods, right? So just like we had over there, the field, which is message, and then the two methods, actually the constructor and the set. Here we're going to have way more. We're going to have the constructor, we're going to have enrolling, we're going to be depositing, withdrawing. It's going to be cool. So we start out by declaring. Actually, let me put it like this. Why is it like that? So when I want to, just like before, I want to declare my smart contract. So I'm going to start out with pragma solidity, right? I am specifying the version over here. So this is the version of my contract, 0.5.8, and it is going to be a simple bank. That's what I'm going to call it. So, oh yeah, I probably need to do this to copy paste. Okay? Or get stuck. So let's go over here while it gets unstuck. And we are going to create. Oh, by the way, if you have any questions, please do write them out and we can answer them later on. Okay, so here we have the version as before, and we have our contract name, which is simple bank. Okay, so look at this. So I saved it and it gave me an error. And obviously, what is the error? It's that, okay, you're using 5.8, so this is different compiler version. So what do? We just go to 5.8, right? And so, let's leave that there. Okay, so we're back here. We don't really need to look at that. Actually, let's just open the file over here. Okay, so we've created a simple bank. Now what we need to do is declare our variables. So what do we really need to have in a bank? So let's not show this. So we need to create the variables that store different things. Okay, let's show this. It's not like you're going to cheat. Okay, so the first thing we need to worry about in a bank, other than, the money, of course, is the clients. So that's the first thing we worry about, the clients. So we're going to create a variable for the number of clients. Okay, so that's this. So that's the client count. And it's an integer. It's an unsigned integer right there. Okay, now the second thing we need to worry about is where to store the accounts. So if a client comes to open an account, where are we going to put this client? So we can create a variable, right? So for the client addresses. Now, obviously, client is not Alice and Bob. Client is 0x27, 239AB, whatever, right? So it's the address, okay? But here we're just saying we're storing them in a variable. What does that mean? A variable for each single person? We can't have that. So we say, okay, let's just add it to an array, right? So we're just adding the clients to the array. But then we say, okay, but these clients have balances, right? So if I open an account, I'm not just a name. I'm a name with money, right? I'm a name with this much money. So what I do is I say, okay, instead of having an array, let me create a map, right? A map of an address, so me to my money. So a mapping of the address to the balance, right? Which is the unsigned integer. Now here we notice something and that I didn't just state before, is that these variables are private. What does that mean? That means that I can only access these variables from inside the account, from inside the smart contract. I cannot call these externally. And also you'll notice that when we actually deploy it like we did before, what is going to happen? We're not going to get the getters, right? Because the getters will not be created for these because they're only for in here, right? We can't access them externally. It's just like in any other object-oriented language, right? So that's what we have there. We have the second idea. And so the variable we create is the mapping, and it's basically a dictionary or in Python, basically, or a map in Java, blah, blah, blah. Okay, then the final third, well, not the final, actually, the third thing we need to worry about is the bank as an institution. So the bank in our scenario has an owner, right? We don't just have a bank like this loosey goosey. We have a manager, whatever we want to call it. We call him an owner. So here the owner is public, right? Because we want to know who this owner is. We want to address the owner, for example. Okay, so we create the owner. Now we have finally this event. I said we were going to go over events. What did we say an event was? An event just says, okay, this happened on the blockchain. So this logs only when a person deposits money into their account, right? So the bank likes to keep track of every time money is deposited into the bank. Yeah, they like to keep track of that. So we will have an event that logs every time a client deposits money into their accounts. Now, this event is not just a variable, it's basically a blueprint that is used over and over, which is just like another function, right? But this function is just this. It's called event, the name of the event, and then what are the parameters. So the parameters for this event are the account address, so who has just deposited money, and the amount of money, which is the unsigned integer. Okay, so this is what's happening here. So I feel like I might need to go a bit quicker, but we're almost done anyway. So we're not going to go into all the details of this. Okay, so this is our event. Now, before moving on to our functions, what do we need to do? We need to create our constructor. So to create the contract, as we said, we need to have this constructor. So now to open the bank, the owner must place 30 ether. That's the requirement. Okay, so 30 ether initial funding is required. Okay, So this require message, excuse me, this require message basically says, unless you have 30 ether, you will not be able to call this constructor. You will not be able to create your smart contract. That's it. So if you do not, if the person deploying, obviously not calling, right? If the person deploying this smart contract does not have 30 ether, you're done. You can't. Okay, so you need to get 30 ether and you need to then, okay, call. Then you can say, okay, I can call my constructor, it'll work. And then what do I need to do in my constructor? I need to say, okay, where I say the message is basically this function. And I'm saying, okay, whoever is the sender of the message will be saved into this owner, right? So the owner, as we know, is an Ethereum address, an Ethereum account. And message.sender is an Ethereum account. So the types are compatible, right? So it's an address, and so is this one. Message.sender is the Ethereum address. And finally, what do we know? That when we create a bank, the client count is 0, right? So we don't have any clients yet. Okay, so we are going to add that here. Oh, this is annoying. So we are going to add that here. So we have an owner that we set. He's public. We have a client count that's 0. That's private. And, well, the mapping is still. So what Solidity does is it creates a mapping and it sets everything to false. Like literally you can put any any address, you can put any address out there and it will give you false or true. So it doesn't just create it with like empty things. It creates it with like any single address, and if you type in any address it will tell you false or true. So if this address actually exists, if I've actually added the account to the mapping, it'll tell me true if it's a Boolean, for example. And if I haven't added it to the account, it will tell me false. Same idea for an unsigned integer. If I haven't added the address, it will give me maybe a 0. And if I have, it'll give me whatever value is in there. So this is not like really a good thing to say, is it in the mapping? It will be in the mapping. You see what I mean? So you can't say is address in the mapping like that. Okay, so let's check it out here. Now we have to, oops, finally, we're getting to the end. We still have 2 functions. Okay, we have to deposit, right? So we have a bank account and I want to deposit into the bank account. Okay, so to deposit something, what do I need to do? There's 2 main things to do in a bank, actually. Let's go. Let's start there. There's 2 main things, right? You can deposit and you can withdraw. And so we need to start with the deposit function right now because that's what we're doing. And to deposit money in the bank, what do you really need? Like if you're going to the bank right now, what do you need to take with you? So basically you need the person to have money, right? And what do you need? You need to have an account. So the deposit function will basically take a certain amount of money, as we see here, right? And what it will do is it will place the money into the client's account. And this will basically be like added into the mapping. So what we'll say is, okay, the mapping, so the map, and we'll say, okay, the message.sender, remember we said message.sender is whoever called the function. So the message.sender, and then we will append to whatever value is there. So it's going to be 0, and then I'm going to say, okay, plus 10, plus whatever value they've given us. And then what did we say? We said that, okay, as mentioned, we want to know that the bank wants to know actually every time a client deposits any money, right? So what did we say we wanted to do? We wanted to create an event. I want to emit an event. So we emit the event and we pass it the address, my address, the person that called the function, and I'm going to pass it how much I just paid, right? So message.value is how much I paid, how much I added into it. So when a function is payable, it basically means I've appended to the function a certain amount of money. So here, when I call the deposit function, I basically say, okay, I've passed you 10 ether. And what happens is this ether gets stored in message.value. So it will append message.value, it will append message.value, right? And here it will have message.sender. So these are all related to the function, as you notice with the prepended message. Now, so what is this? Returns uint. This is the return type. It returns an integer, right? So it returns what? The current amount. So after we've appended, right? After we've added, okay, he had $10 plus, well, 10 ether plus 10, it's now 20 ether. This will now return 20, right? This is just so that the customer can know how much money is in his account. I don't really think we have to copy paste it anymore. We don't really have time to actually run it out. So we're just going to talk about the last function before stopping. The last function is the withdraw function. And so we're going to continue by saying, okay, what do you need now? What do you need to withdraw money? Well, basically, you need a client with an account and an amount to withdraw. So here you notice that the amount is actually placed as a parameter. Before, it wasn't placed as a parameter. I think I may have said that, but no. So it's payable, right? So as we said here, it's payable. So it's placed into the function itself. And this is a technicality. You can't really see this here, but on Remix, you'll notice where to place that, but we're not going to do it, okay? So anyway, for the withdraw function, you're going to say, okay, how much do I want to withdraw? And also it returns, basically it returns how much the total balance is after you've withdrawn. Okay, so the money is removed from the mapping just like we did before. So here we say, okay, message.sender, and I'm going to withdraw the certain amount. So here we say, what could really go wrong? So imagine that a client tries to withdraw more money than they actually have. Yeah, that's pretty bad, right? So what we need to do is we need to put something in place to make sure all goes smoothly, right? We don't want anyone to take more money than they have. So what we need to do is make sure that the amount they have is at least as much as they want to withdraw. So what we do is we create this if statement right here. And this if statement says, okay, as long as the amount you want to withdraw is less than or equal, you can withdraw all your money. No one cares. As long as it's less than or equal to that amount. And what amount? The amount you have in your bank, right? So the amount that you have in this array, this mapping at this value. So your account. And as long as this is true, then I will allow you to withdraw from your account. Okay, there's actually something here, right? And here we need to say, okay, I need to return the balance at message sender. Just like we said, we need to return the amount. Okay, so that's like the more complicated version of a smart contract. We really didn't get into like the really hard functionality of it, but that's because like this is like an intro kind of course. So I really hoped you enjoyed this presentation. I hope you really like understood the concepts of blockchain, and it was really important to go into these blockchain concepts before moving into Ethereum, because Ethereum at the end of the day is a blockchain platform, right? So I hope this was clear. I hope you enjoyed the smart contract, the first one, and then I know the second one was a bit rushed, but you know. So that's
Thank
that.
you.
Thank you guys for watching.
It
Thank
was
you, Anna.
super helpful. Thank you so much. And so we're running a little low on time. I'd just like to end it with if you have any kind of brief advice for someone who's just starting out with developing for the blockchain.
Oh, you're asking me. Okay,
Yeah.
so blockchain in general or Ethereum? So I feel like general advice for this is, read up, do your research, because you can't just like throw yourself in like let's deploy a smart contract, or let's just, create an account and see how it goes. Just like do your research before going into it. See, okay, what do I need? Do I have enough resources? My computer? Can I just like create it? Can I actually create a decentralized application on my own? What are the frameworks I need? You just research in general. Like I say, that's the best. That's the best way to start.
Okay. Thank you so much, Raphael. Thank you for your time. And thank you, everyone who watched the live stream. I hope everyone has a good Eid and a good day. And we'll see you in the next workshop. Bye bye.